We live in a world where everything feels real, where it seems like we can actually reach out and touch the things around us. Stones feel solid and unyielding. Snow feels soft and light. Jam is sticky and gooey to the touch. And time feels like a straight river that flows endlessly in just one direction. These sensations come to us so naturally, as if we've known them since the moment we were born. But today, we're not just here to talk about the strange and puzzling world of the microscopic. We're taking things further, from certainty to doubt, and from doubt to a bold and mind-bending hypothesis. What if the universe itself is just executable code, and what we call consciousness is nothing more than the interface of an observer? Hey everyone, welcome! By the time you finish this video, the way you see the world around you might never be the same again. So let me ask you, is the world you live in truly real? And more importantly, is your life, the one you're living right now, actually real at all? Or could it be nothing more than a single line of code, something that could be erased or rewritten at any moment without warning? You've just arrived at our channel, and we're so glad you're here. So let's dive right in and get started. Is the observer actually the designer? The moment we start peering into the inner workings of matter, the reality we've always taken for granted begins to collapse like a fragile house of cards. Atoms, the very building block that make up all physical matter, are, in truth, almost entirely made of empty space. In fact, over 99.9999% of an atom's volume is completely void of anything at all. For example, if we were to enlarge the nucleus of a hydrogen atom to the size of a soccer ball, its lone electron would be floating nearly 4.5 miles away. The ratio between that nucleus and its electron is about the same as a single grain of rice sitting on the center of a football field, while a tiny mosquito buzzes around far outside the stadium walls. And in between them, nothing, just a vast, silent stretch of empty space. But even that tiny electron doesn't really have a solid form in the way we usually imagine. That's because it only chooses a specific position at the very moment we observe it, a deeply strange behavior that defies all common sense. At all other times, the electron is vague, uncertain, almost ghost-like, existing only as a cloud of probability, like a shimmering ornament on Christmas Eve flickering in the reflection of a fireplace flame. It's a reality that feels oddly similar to something out of a video game. On screen, the scenery only appears when we're looking directly at it. Move the camera just slightly to the left or right and that image vanishes, instantly replaced by something else. In a computer-generated world, everything is rendered in real time, only when needed. Gamers call this process rendering. The game only draws what's directly in the player's line of sight, and everything else simply disappears the moment you look away. So what if the space around us, the world we walk through every day, is nothing more than an interface? And what if particles themselves are actually fragments of computer code, written to respond when we observe them? The deeper we dig, the more the idea of a solid, reliable reality begins to slip away. When scientists tried to measure the behavior of particles, they were stunned to discover a shocking truth. The act of observing those particles actually changed the results. And it all began with a deceptively simple experiment. Physicists fired a stream of electrons, like beams of light, toward a plate with two narrow slits cut into it. Now, electrons were always assumed to be particles, tiny balls of matter, nothing more. If electrons really were particles, then they should simply pass through one slit or the other, and we'd expect to see just two bright lines appear on the screen behind. But what actually showed up was something completely unexpected, a series of alternating light and dark bands, an interference pattern, just like you'd see with waves. It looked as if the electron had acted like a wave, passed through both slits at once, and somehow interfered with itself. So the researchers said, all right then, let's find out which slit the electron is really going through. They set up a detector to track the electron's path as it moved through the slits. And the moment they did that, everything changed, dramatically. The interference pattern vanished. The electrons began behaving exactly like ordinary particles, producing just two bands on the screen, just as expected. It was a true paradox. When no one was watching, the electron behaved like a wave, spreading out, occupying multiple places at once. But as soon as someone observed it, it snapped into place and acted like a single particle choosing one specific path. The act of measurement itself, just trying to observe, actually changed the nature of the matter being observed. This discovery rocked the world of 20th century physics so hard that science, even now, still hasn't fully recovered from the shock. The results of the double-slit experiment feel like a direct challenge to common sense itself. In the end, it seems that reality depends on whether or not we're looking. In a computer game, this kind of behavior doesn't feel strange to us at all. The game only renders what the player is actively looking at. Anything outside the player's line of sight is simply left out to save processing power. But we accept that behavior without outrage, only because we know it's just a game. If we truly believed that kind of thing was happening in real life, it would pull the ground right out from under us, leaving our sense of self flailing in the void. Because in that moment, everything we know would start to feel fragile, fleeting, and unreal. And when we realize that the very same thing might be happening in our own physical world, we instinctively reject the idea. We push it away just to stay sane. Otherwise, we'd have to admit that we might be nothing more than background code in some sort of simulation, or players inside a virtual shooter. Maybe we're just expendable units getting picked off one after another in games like Stalker or Call of Duty. We're not the masters of our own fate. We might just be slaves, bound by invisible lines of computer code. Quantum teleportation, disappearing there, reappearing here. If the double-slit experiment showed us that the behavior of particles depends on the observer, then quantum teleportation revealed something even more shocking. In the microscopic world, the very concept of distance starts to fall apart. Physicists took two photons and entangled them, linking them so that whatever happened to one would instantly affect the other, no matter how far apart they were. Then they introduced a third photon and transferred its quantum state into one of the entangled pair. And what happened next was absolutely astounding. That same quantum state appeared instantly in the other photon, even though it was far, far away. And the original photon? It vanished. In other words, the information was completely destroyed at one point and instantly reconstructed at another. It didn't travel through space, it simply reappeared, elsewhere. It feels like something straight out of a computer game. The main character steps into a portal and, in the blink of an eye, reappears from another portal hundreds of light years away. Even if that other portal is sitting on the very edge of the universe, it makes no difference. In a digital world, distance doesn't mean anything at all. But this isn't some video game. This was a real experiment carried out in a real laboratory. Today, quantum teleportation is already being used in quantum cryptography, and before long, it'll become the foundation for quantum computers. But this brings us to a deeper, more fundamental question. If information can jump instantly from point A to point B, then what exactly is space in the first place? Maybe space isn't the foundation of the universe, but just a kind of interface, like the coordinate grid in 3D modeling software. The more we look, the more all of this starts to resemble a program running behind the scenes, not a set of natural physical laws. The state of a particle begins to feel more like a variable in a line of code. Deleted here, rewritten over there. Maybe this world isn't a stage for matter at all, but a kind of computational system where results matter more than process. And if quantum teleportation suggests that distance might be an illusion, then the next phenomenon we're going to explore flips the entire idea of movement itself completely on its head. Quantum jump, an elevator with no floors. Inside the atom, electrons don't orbit around the nucleus like moons circling a planet. Instead, each electron exists only at specific preset energy levels, nothing in between. And the strangest part? An electron can leap from one of these energy levels to another instantly, without ever traveling through the space between. Picture an elevator that doesn't move from the first floor to the fifth, but instead, the first floor vanishes and the fifth just pops into place out of nowhere. There's no movement, no acceleration. All you have is a beginning and an end. That's it. Physicists call this bizarre behavior a quantum jump. Stripped of the technical jargon, it's kind of like a line of computer code, a command that says, move this object to state B. There's no animation, no transition. The program just switches a variable from one value to another, clean and instant. But this isn't chaos, it's a system of incredibly strict structure and rules. The energy levels allowed inside an atom are fixed. Only certain exact values are permitted, and nothing else exists in between. An electron can never pause or hover in the middle of those levels. It can only exist here or there, nowhere in between. It doesn't resemble the continuous flow of nature we're used to. It looks more like digital logic, the kind you'd see in a program that operates with discrete separate values. Code embedded in atomic structure. But quantum jumps are just the tip of the iceberg. The real mystery lies hidden deep within the geometry of the atom itself. Electrons aren't just randomly scattered around the nucleus. They're precisely arranged in layers known as electron shells. And those shells don't fill up randomly. They follow a strict pattern: 2, 8, 18, 32, and so on. But why does it work that way? Why not 7 or 13 or some other number entirely? This sequence isn't a coincidence. It's a built-in rule embedded in the very foundation of matter itself. As if the universe is running on a pre-programmed algorithm, following strict instructions from the start. And this is only the beginning. Inside the nucleus, there are certain numbers of protons and neutrons called magic numbers, and when an atom contains them, it becomes especially stable. These same numbers appear over and over again across different elements. Can that really be just a coincidence? Or are they reused fragments of code, repeated by design? Even the quantum numbers that govern a particle's properties, like spin, orbital angular momentum, and energy, all follow rigid, unbreakable rules. Electrons never behave on a whim. They're bound by protocol, a fixed set of conditions that can never, ever be violated. And this leads us to a chilling conclusion. Life, chemistry, biology, even consciousness itself, might all be nothing more than the result of algorithmic structures embedded deep inside atoms. If even a single line of that code were wrong, molecules wouldn't form, DNA wouldn't exist, and thoughts themselves could never arise. Swedish-American physicist and cosmologist Max Tegmark, a professor at MIT, argues something radical. He claims this universe isn't made of matter, but of pure mathematical structure. And James Gates, an American theoretical physicist and professor at Brown University, discovered something stunning hidden in the equations of string theory, a structure nearly identical to binary computer code, more precisely, an error-correcting code used in digital technology. And if that's true, then the world we see around us might not be natural reality at all, but a world that has been calculated, step by step, by a predetermined formula, a world that exists purely as an interface. Matter without substance. When we touch a table, it feels solid beneath our fingers. When we pick up a stone, we trust, without question, that we're holding something real, something made of matter. But modern physics tell us something else entirely. That sense of solidity is nothing but an illusion. Particles aren't tiny balls, and they're not the fundamental building blocks that make up our world. Particles are events. They are brief flashes, fleeting occurrences that spark into existence within invisible quantum fields spread across the entire universe. Electrons, protons, photons, none of them are actual things. They're just local ripples that momentarily appear in those quantum fields. Think of them like ripples on the surface of water. They're there while the wave is moving, but there's nothing you can grab, nothing with true physical substance. And what's even more astonishing is this: each of these fields exists everywhere in the universe, all at the same time. The electron field, the photon field, they're not confined by space. They stretch out endlessly, filling everything. What we perceive as particles are nothing more than tiny, momentary clicks, brief flashes of interaction that light up within this vast, ever-present background. In other words, the solidness we think we feel in this world is just a convenient illusion, generated by our interactions with quantum fields, tailored to our conscious experience. That's right, it's a carefully constructed illusion, designed to keep our interface with reality running smoothly. When you really think about it, this isn't a world of physical matter. It's more like a virtual machine, not built on solid particles, but on flexible, universal code. Everything we see is simply a visualized interface, rendered for the user, nothing more. The point of no return. We could spend forever marveling at the elegance of quantum equations, debating the nature of fields and symmetry, or searching for simple answers to deeply complex paradoxes. But then comes a moment when all of those paradoxes suddenly snap into place into one hauntingly perfect and terrifying picture. Atoms are, for the most part, made of nothing but empty space. Electrons aren't really particles, they're probabilities. Space itself is nothing more than an interface. The idea of distance between objects, it doesn't truly exist. What we think of as matter, as real solid stuff, is just the effect of interactions between invisible fields. All of these truths start to feel less like discoveries in physics and more like parts of a script, a scenario written with strict logical rules. And then a chilling thought creeps in. What if these aren't paradoxes of physics at all, but steps in a simulation manual? What if we're not living under mysterious laws of the quantum world, but inside a system, a program, where those laws are simply optimized algorithms? And this is the point of no return. Because once you allow yourself to wonder, what if the world is a simulation, you can never go back to seeing it the same way again. The stone in your hand no longer feels like just a stone. The question, is my life real, no longer sits in the realm of abstract philosophy. It becomes personal, a question aimed straight at you. So then, who are you? Are you a living, breathing human being? Or are you just a single line of code waiting to be executed? And if the universe is a program, who wrote that program? And here's the most unsettling question of all. If this world is an illusion, then who, or what, is watching it all unfold through your eyes? Who's holding the controller? If you found today's video interesting, please give it a thumbs up and share it on your favorite social media. Thanks so much for watching. Until next time, see you soon and goodbye.